Hey everybody, my name is Jason. I am a senior researcher in symbolic artificial intelligence at the Singapore Management University Center for Computational Law. I am also a sessional instructor at the University of Alberta Faculty of Law, where I teach coding the law. And I'm very happy to be here today to chat with you about the programming language that we're working on at the Center for Computational Law, which is called L4. And what I'd like to do is kind of give you a basic understanding of why we would even want to write a programming language for law, and what do we hope this one is going to be able to do. So you have to start out with a problem that you're trying to fix. So the problem is legal services must be and are being automated, but encodings of legal knowledge are hard to write, hard to read, hard to verify as legally correct, not very reusable, and very, very difficult to maintain. So what does that mean? Well, this is when you take legal knowledge and you put it into a software programming language. First of all, the programming languages are difficult to learn. They're hard to write because you usually need an expert in the law and also an expert in the programming language sitting beside each other to actually create the encoding. They're hard to read because they're written in the programming language, and most people who understand the law can't read the programming language. They're hard to verify as legally correct for the same reason. A lawyer is not going to give a legal opinion on a contract written in a language they don't speak, and most lawyers don't speak code. So it's difficult to get an authoritative opinion that your code is correct, certainly not by reading it. What you can do is you can have the legal subject matter expert use your software and have them test it by using it. But that process is very unreliable for figuring out whether or not your software is actually correct because of the varieties of ways that it could possibly be wrong. And when we write code in the languages that we have now, they tend to be programs that are only able to solve one problem, and we can't reuse them. So if we have another problem that's in the same area of law, we need to get our legal subject matter expert and our programmer back together and have them write new code. And then let's hope the rules don't actually change, because if they do, it's very difficult to figure out what parts of the code need to change as well. Essentially, if any of the rules change, you need to review all of your code. All of these are reasons why you don't see more automated legal services than there are now. They are very hard to create and they're very hard to maintain. The other problem is legislation and contracts are a critical part of our legal system, and they are increasingly being automated, but they are badly drafted and difficult to interpret for the purpose of encoding. So if you know exactly what the law or the contract means, you still have all of the problems on the previous slide. But you usually don't even know what the law or the contract means, which is another problem. So now we have some ideation. What if we could be confident in what the legal rules meant and they were easy to automate because they were written in a language that computers can understand and the computers helped avoid mistakes and omissions in the first place? That's the idea behind L4. And this is the address for the open source repository. SMU Center for Computational Law operates by the open principle. So all of the software that we're writing is open source software, and everything that we're doing, you can watch us as we're doing it. So that's the address where the software that I'm showing you today is located, and you can download it. So here is a diagram of the idea of what L4 does and how L4 works. So you start out with a law or a contract that you want to automate in some way that you want to do something with. A human being then interprets that law or that contract, and that human being writes code in L4. That's our programming language. Then we provide a number of software tools that will translate that L4 encoding into encodings in other existing systems that are available today, but are just too difficult to use for legal purposes in their current states. So depending on what you want, L4 will get translated into different things. We can encode it into a language that can be used for natural language generation. We can encode it into a language that can be used to generate smart contracts. We can encode it into a language that can be used to do formal verifications, to build expert systems, or for rules as code purposes. So that's the basic idea, is that we are trying to write a language that is going to be easy to use on the left side for human beings, and that computers are going to be able to use to do all of the things on the right side. So as an example, I wanted to look specifically at natural language generation, and part of the reason is because I can show you something that L4 already is able to do. So we use a software tool, also open source, called Grammatical Framework for natural language generation in L4. And what is natural language generation? Basically, the idea is if you write code in L4, that code can be given to a piece of software, and that piece of software can translate your code into English or French or Swedish or all three at the same time. So why do you want to generate natural language from encodings of law? Didn't we start out with a natural language version of the law? Why do we want to go from natural language to encoded language and then back to natural language? Well, there's a few reasons. One, it gives the code the ability to explain itself in plain language. It also can be used by subject matter experts to verify whether or not the code correctly matches their understanding of the meaning of the law. Because if the L4 code is too difficult to read, presumably the natural language code, the natural language that L4 generates would not be too difficult to read. And one of the things that you need to do with legal rules is you need to generate legal documents. And natural language generation can be used to generate sophisticated legal documents on the basis of rules. So that's why we're interested in doing it. And here's an example of how this works. So let's say we have an imaginary contract for the sale of cabbage. And Section 4 of this contract says, for the purposes of this contract, cabbage is defined as an item of the species Brassica chinensis or the species Brassica oleracea. So that's our natural language original contract. Now, a human expert is going to have to translate into L4, and this is what the L4 version of that clause would look like. This is the current syntax that we're working on for L4, but it is an ongoing, it's a living tree, as we say in Canadian constitutional law. It's an evolving thing. So by no means is this necessarily what the syntax of L4 will be a year from now, but this is what it looks like right now. So you can see it's relatively readable, right? It's not completely opaque, and it uses more words than it does symbols, all of which is designed to make it accessible for people who are subject matter experts. So I said before that we take our L4 coding and we create tools that translate it into other languages that can then be used to do useful things. So in this case, the other language is the grammatical framework. And we have code that will take this L4 encoding and will translate it into this, which is almost unreadable, but this is essentially the same thing, but said in the grammatical framework software using a grammar that has been generated for the purpose of expressing this same contract. Now, generating this code, this GF code, is being done automatically. Right now, generating the grammar that was used to generate this code is being done manually. That's one of the things that we're still working on automating. So this isn't yet a completely automatic solution. There's still manual parts. But this part, once you've written the grammar, this part can be generated from L4. And then once you have this, grammatical framework is able to turn it into this. An item is a cabbage when the species of the item is Brassica chinensis or Brassica oleracea. Now, that seems almost too good to be true. That what you gave the computer was this, and what you got back was that. And it is true. The hard part, it turns out, is not getting the computer to generate the language. The hard part is generating the grammar so that the computer knows how to generate the language. So I'm going to see here if I can, well, what I'm going to do is I'm going to just demonstrate that this is actual running code. And I'm going to go back to this slide here. Grab that. I'm going to copy that. Okay. Now I'm going to stop my share, and instead I am going to share a command prompt on my computer here. Give me just a second. Okay, that should be visible for you shortly. So I'm going to go into the folder here. I'm going to say that and start the grammatical framework software. And when it has loaded its grammar, I'm going to ask it to convert that line of GF code into English. There we go. So I'm going to say L, which means linearize, which means take the code and turn it into language. I'm going to paste in the code and hit enter, and you can see the software spits out an item is a cabbage when the species of the item is Brassica chinensis or Brassica oleracea. I'm just going to go back to the presentation here. All right. So that is an example of natural language generation in L4. And this is, even with L4, which is a relatively readable computer language syntax, this is the task that would usually be in front of a lawyer who was asked to verify whether or not a piece of code correctly matched what a law says. Now, let's be real. In the vast majority of cases, the situation is much worse than this. In the vast majority of cases, the legal text is not separate from the rest of the code. The legal text is not in one part. that you can point the lawyer to and say, hey, just read this section of code because that section is the law and everything else is how I designed the web page or what have you. In most cases, when people build legal apps right now, the meaning, the legal meaning, and the application meaning all get mixed up together. And so you can't even provide something like this to a lawyer and ask them if it's right. But if you wrote it in L4, you could conceivably give this to a lawyer and say, hey, did I get this contract right? That's not bad, but it's not great. What the natural language generation tool gives us is the ability to ask this question instead. And that's something that it is 100% realistic to think that a legal subject matter expert, a lawyer or somebody else, is going to be able to read and say, yeah, it looks to me as though the semantic meaning of what you have written in L4 is identical to what I think the rule means. You can also test it, and because it's written in L4 and you have access to other tools, you can test it in quite sophisticated ways. That is called formal verification. And formal verification is achieved by taking your L4 code and translating it into the language used by a model checker or a specification language. And these are tools that are used primarily in software and hardware engineering, but there's no reason we couldn't use them in law. They could be used to detect loopholes, detect under specification when there's something that you probably wanted to set out, but you didn't. It can also detect unintended consequences. You can say, this is a scenario that I definitely don't want to have happen. Like at the end of the contract, it should not be the case that one person has all the money and all the cabbages. And you can have the software check all the possible scenarios under your code and see if your code is capable of generating that scenario. And the benefit is that you could potentially avoid costly and complicated litigation over unclear drafting. It also just means that your laws are going to be better written and your contracts are going to be better written. And then, because you've got it in an encoded language, you can also translate it into a language like a logic programming language, something that uses an event calculus perhaps, and you can create expert systems. And an expert system is capable of answering legal questions about a specific fact scenario. They're capable of being generated just by loading the code and asking a question. There's nothing more to it to build a legal services app if you already have an L4 encoding of the contract or the law. An app is literally a click away. And they're capable of explaining their answers and providing references to the source material. And they are also capable of answering questions that go beyond, is this legal situation true? But how can I make this legal situation true? Which instead of deductive reasoning is called abductive reasoning. What facts would need to exist in order to get this legal outcome? And that's a thing that it's possible to do with an expert system that can be automatically generated out of L4 code. So that is my brief little introduction. Again, I'm working with Singapore Management University's Center for Computational Law. We just started working about 6 or 7 months ago. It's a joint venture between Singapore Management University's law school and a company in Singapore called DLIS. And that is the website, and that is the GitHub organization name, so that you can go and check all of our repositories, download the code and play with it if you like. And that is the email address. And I am Jason, and I am Gauntlet173 on GitHub. So if you want to look at the code that I'm writing in particular, that's where you would find it. I'm also Jason at roundtablelaw.ca if you want to get a hold of me by email, but the easiest way to get a hold of me is actually Twitter, where I am Roundtable Law. So thanks very much for your interest in this. I'm sorry that the timing doesn't work out for me to be able to join you in person, but I'm hoping that this is kind of scratched an itch to find out why in the world would people be going to Singapore to write programming languages for law. All right, thanks a lot.